We're going to be making this Flappy Bird clone, and I know it may look ugly, but that's because we're focusing our time on important game development concepts that you need to know that for some reason none of the other Flappy Bird tutorials are covering. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream projects sooner. And as you can see, we're going to be building a simple Flappy Bird clone in this video, but we're going to be covering all the important game development concepts no one else seems to be covering. So to get started, let's first just create an index HTML file, which is where all of our HTML is going to reside. We're also going to create a simple script.js file and a styles.css file so we can have some styles as well as some code in our script.js. And then the very first thing I want to do is just import those. So we're going to do a link tag for our CSS called styles.css. And we're going to do a script tag here. And this is going to be for our script.js file. And we're actually going to be using modules inside of this project. So make sure you set the type here equal to module, just like that. And if you're unfamiliar with what this type module does, I have an entire video covering it. I'll link in the cards and description for you. With that done though, we've pretty much covered most of the HTML because this project is going to be mostly JavaScript generated, but there are a few things we need to add. The first thing I want to add is the title screen. You can see when I refresh this, it says press any key to start. And then when the level fails, you can see it press any key to start. And it also has a little subtitle down here telling me how many pipes I've passed through. So we can just have a simple h1, which we're going to give the class of title. And inside of here, we're going to put that text of press any key to start. And then I want to have a subtitle, which I'm going to use this small for. We're going to give it a class of subtitle. So we'll say subtitle. And we're going to say hide as well, because by default, we want this to be hidden since we don't want this to show up when we first refresh our page. And inside of here, we're not going to put anything because in JavaScript, we're going to add this text in. And since I'm selecting this in JavaScript, I'm going to add a simple data attribute called data subtitle to make this easy to select in the JavaScript. Now, the next thing I want to do is just have a div. And this div is going to have a class of bird. And again, I'm going to add a simple data attribute called data bird so we can easily select this in our JavaScript. And this is just going to be that yellow circle that you see on the left-hand side of the screen. So now with that out of the way, let's actually open this up using Live Server, which is a VS Code extension you can install. And as you can see, we have that press any key to start showing up. And let's just close out of this other version. Now, the first thing I want to work on before we start jumping into the game development code is a few styles just to give us a general look and feel for this. So let's come into the styles. And the first thing I like to do in every style sheet is just to do a selector for everything for the before and the after pseudo element, just like this. And I like to set my box sizing here to border box. If you're unfamiliar with what this does, I have an entire tutorial on it. I'll link in the cards and description below, but essentially it makes sizing things a lot easier. And the next thing I want to do is I want to take our body. I want to remove all the margin. And I also want to make sure that our overflow here is set to hidden. And that's because when we have our pipes on the screen, they may go off the screen at some point, and we don't want those to make scroll bars appear. That would be really bad. Now, the next thing we can work on styling is that title, as well as the subtitle. And if you remember right, we have a hide class that we added to our subtitle. So we want that hide class to just say display none. And there we go. So that's hide class done. Next, I want to work on our title. First, I want to make our z index 10 so that way it'll appear above everything else. And then I want to put it in the dead center of our screen. So we're just going to position this absolutely. We're going to change the display here to flex. We're going to justify our content in the center. We're going to align our items in the center. This is going to give us everything in the center. And then in order to make sure that it actually shows up 100% in the center, because as you can see when I save this, nothing's actually changed, I want to change my inset here to 0. That'll set the top, left, right, and bottom property of my title to 0. And that's going to make it so that my title expands across the entire screen. And now it is perfectly centered, as you can see. Also, I want to get rid of any margins that are on here by default, and that's just going to help with our subtitle. Now, the only thing I want to do on our subtitle is just add a small margin to the top, which will space out our subtext from our main text. So if I put, for example, 0 pipes in here, and I save, and I make sure to remove that hide class, you can see that that's showing up here side by side, but what we want to do is make it show up below. So we can just change our flex direction here to column, and that's now going to make it show up below. And there we go, that's all we need to do for our text portion. Now we can actually work on the styling for our bird. So let's just come down here, select our bird, and we know that our bird is going to have this yellowish color, so we can change our background color here. We're going to use HSL. We're going to use 50 as the hue, 75% as the saturation, and 50% as the lightness. That's going to give us that nice yellow color. And if you're unfamiliar with HSL, I have a full tutorial on it. I'll link in the cards and description. And the next thing I want to do is position it using absolute positioning. That's because in JavaScript, we're going to be positioning this with JavaScript. And then I want to set a CSS variable for our bird size. And that's because we're going to be referencing this variable all over the place. So I want to just have it in one place where I can change this value once, and it's going to reference the rest of our code. So for example, our width is going to be that variable, which is bird size. Also, our height is going to be the exact same thing. We're going to put our height here. And we're going to also add in a left position, which is going to be our bird side as well. And that's because I just want this to be positioned away from the left side of our screen. If we get rid of this, our bird's going to show up right on the edge of the screen, but by adding this in, you can see it's now pushed away from the edge of the screen. Also, to make this a circle, let's set our border radius here to 50%. That's going to give us a perfect circle. Now, the last thing I have to do is position the top position. So our top is going to also be set to a variable, and this variable is going to be our bird top variable, but this is a variable that we're going to set inside of the JavaScript, and that's because as we push the spacebar, our bird is going to go up, and over time it's going to fall down. So this top is going to be set by JavaScript. So for example, in JavaScript, I'm going to set our bird top to a value such as 50, but I'm not actually going to say 50 pixels, I'm just going to say 50. So we need to actually convert that value of 50 to a pixel value, which we can do with the calc property. And here I can just say times 1 pixel. That's going to convert this to a pixel value. So now when I save, you can see it's been moved 50 pixels down from the top of our screen. Now for our use case, we want to hide the bird by default. So we're just going to set this to like -1,000 or 10,000, doesn't matter. It's going to hide it off the top of our screen. And then when our game starts, the JavaScript is going to put the bird in the correct position. And with that done, we have most of the styling done that we need to do for now. So let's move over to our JavaScript to actually make it so when we click any key, it's going to start the game. Also, I want to go back to my HTML here and just add in that hide class and remove this default text. So we're back with our start screen. So jumping over into our JavaScript, we essentially want to have two different types of functions. We're going to have a function called handle start, and this is going to be what we call when we want to start our game. It's going to essentially reset everything. Then we're going to have another function called handle lose. And this is what's going to happen when we lose, when we collide with a pipe or run off the screen. This is going to stop the game from running, and this right here is going to start the game from running. And we can call these interchangeably, so I can click start to start it, and when I lose, I can call start again just to restart the game, so that way they don't have to refresh the browser page. So what we want to do is first come up here, we can say document, add event listener, and we want to add an event listener on key press. So whenever we press any key, I want to call a function, which is the handle start function, and I want to make sure this only happens one time. So I'm going to set once to true. Now, if you're unfamiliar with this fancy syntax that you see for this event listener, I have a full tutorial covering it. I'll link in the cards and description down below. So now every single time we press a key, the very first time it's going to call this handle start function. Now in this function for now, we're not going to actually do much. All I want to do is I just want to come in here and I want to get our title element. So we can say document.querySelector, and we want to query selector the data title. And if I go to my HTML, just make sure that on our title, we add data title. Now we can select that properly. And inside of here, I just want to say title.classlist.add, and I want to add that hide class so that the title is no longer shown. So now if I press a key, you can see that our title is hidden. So far this is working as we expect. Now the next thing that we need to do is actually to start up our game, and almost always when you're creating a game, you're going to run inside of a game loop. And a loop is essentially something that's just going to run infinitely, running and calculating all the different calculations for your game, and it's running very, very quickly. And in order to create a game loop inside of JavaScript, you want to use window.requestAnimationFrame. So we can say window.requestAnimationFrame, and all this does is takes a function. We're just going to call this function update loop, and let's create that function now. We'll just come up here, function update loop, just like that, and it takes in essentially a time, and this is the time since your page started running. And we can just come in here, we can say console.log time. So now if we just come over here, click space, you'll notice nothing happens, but if I inspect and I go over to the console, you can see the time has been printed out. That's essentially how long in milliseconds it's been since my page started running. But you'll notice this update loop only ran one time. And that's because in order to get it to run again, we need to call this window.requestAnimationFrame again, and that's going to recall our loop on the next animation frame. So now if I save and I press a key, you're going to notice in our console, it's doing a ton of logging. It's just printing out all of the different times, and it's printing them out every couple milliseconds. And the reason that this is working as we see is because request animation frame is going to say, hey, every single time that we now have the ability to change what's on the screen, render out the code inside of this update loop. So it's always waiting until the next available time for you to be able to draw things onto the screen, which is perfect for game development because every single time we can change what's on the screen, we want to update the position of the pipes and the bird and so on. Now, most tutorials on this topic are going to use set interval here instead of request animation frame, and that's a very bad idea because set interval is not very accurate, and it's also not very performant, while request animation frame is going to be accurate and performant. And best of all is we are going to be able to calculate the time between each update loop. That way, if our person that's playing the game for some reason has a few frames that they drop, and for the example, the update instead of taking 10 milliseconds now takes 30 milliseconds to update, we're going to be able to account for that and make sure our code works no matter what. This is actually a bug you see a lot in even major titled games, so this is going to be something that's really important to learn about. So the first thing we want to do is we essentially want to get the last time we updated. So we can create a simple variable. We're just going to make it a let variable called last time. And that's going to be the last time that we went through our update loop based on this time variable here. So all the way down at the bottom, we can just say our last time is equal to time, and then we're going to call our loop another time. And this is going to allow us to track the time between these calls. So what we can do here is we can just say, what's our time minus our last time? And that's going to give us the time between our different renders. So if we just save and I come over here and I inspect our console real quick, and I click spacebar, you're going to notice it prints out a bunch of information. But if we go to the very top, you're going to notice at the very top we get NaN, and that's because by default, our last time doesn't have any value. And if we were to default our last time to 0, for example, you may think that would solve the problem, but actually, if we go all the way top, you can see our time up here is really large, and that's because request animation frame, the time starts counting from as soon as the page is rendered. So there's a really easy way to get around this issue. Essentially, we're going to skip our very first loop. So if our last time here is equal to null, then what I want to do is something special. We're just going to skip out of this loop essentially, and I want to set our last time. So we can say our last time is going to be equal to our current time. We're going to make sure that we call a new animation, and then crucially, the thing that we're going to do here is we're going to return. And that's going to make sure that every time we call time minus last time, it's always going to give us a small number. Now if I inspect and I go over to our console again, you can see we click spacebar, and of course we're getting last time is not defined. That's just because I got rid of the variable up here. It should say last time. There we go. Now with that fixed, if I hit start, you can see if I scroll up to the top here, our very first render out here is essentially, it's a large number, but it's still a small enough number that we can work with this. It's not some massive number like 200, 300, or 1,000. It's a small number. And that's perfect. That's exactly what we want. So all this is doing is essentially saying, hey, skip the first render, and then we're going to start rendering from there. Now this time minus last time is actually important. This is something called the delta. That's what we're going to call it. And essentially that's the time between different animation frames. So if we have a long time between animation frames, we want to make sure we move the bird further, while if we have a short time between frames, we want to move them less. So this delta is a variable we can use to make sure we always move according to how long it has been since the last frame. Now I know this is probably a fairly confusing concept until we actually start using it. So what I want to do is I want to create a function called update bird. I'm going to pass the delta into that. And then what I want to do is I want to create a brand new class called bird.js. And this is going to contain all the code for our bird related stuff. And we're going to make sure we export a function called update bird, which takes in a delta. And this function is what we're going to use in our script.js. So up here, let's make sure that we import that update bird function from bird.js. So now we have that function right here that we can access, and inside of here we can actually update our bird's position, and we can use that delta to make sure we fine tune the position, so if delta is larger or smaller, it's going to compensate for that. So let's just make it so our bird falls by default. So what we can do is we can set the top position of our bird. So first we need to get our bird element. We're going to say const bird elem is equal to document.querySelector, and remember we gave that a data bird attribute that we can select on it, just like that. And then in order to set this top variable, which we have inside of our CSS, this bird top here, we're going to create a few helper functions. One is going to be for setting the top, and it's going to take in a top value. And we're going to have another one for getting the top. And these helper functions are great because the actual code for getting and setting is pretty complex. So inside of our set, what we need to do is we need to take our bird element, we need to get this style, and what we want to do is we want to call set property, pass it the name of our property, which is bird top, and pass it our value. Pretty straightforward. Our get top is a little bit more confusing. We want to call a function called get computed style, and here we pass it our bird element. Then we can call get property value and pass it in the value we want, which is bird top. And we need to use this get computed style because the CSS value is actually a computed style, and we can't just get it with the normal .style syntax like up here. So now we can just say console.log get top. And this should hopefully get us -1,000, which is the top value we specified. So if we inspect, go to our console, and I click spacebar, you can see it prints out -1,000. So this is working as we would expect. Now by default, we want to update the bird's position just to make it constantly go downward. So we could just say set top, and we're going to take our current top, and we're just going to, for example, add on some speed. So we could say like bird speed. And up here we could set our bird speed. So we'll say like bird speed is equal to, let's say 5, for example. And then in order to see this in action, let's just change our top here back to 0. And let's also make sure that when we get our top, we actually parse this as a float. So we want to make sure that this is a number instead of a string, because if we don't do this, it'll come back to us as a string. So now we have it as a number. We're going to take that number, add our speed, and that should hopefully drop us down. As you can see, we slowly drop downwards. That works great, but the problem is if our frame rate changes, this bird speed is always going to drop us by the same amount, even though if our frames take way longer, for example, one frame takes half a second and the other frame takes 3 seconds, our bird will still move the same amount in half a second as it moves in 3 seconds. We need to change the bird speed based on our delta. We're going to take our bird speed and multiply it by this delta. Now when we hit start, you're going to notice it moves much faster, and that's because this delta is a positive number like 5 or 6 or 7, but it's always going to be consistent. So if we just drop our bird speed down to like 0.5, let's say, and now we hit start, you're going to see it again moves as we would expect, but now it's going to always be consistent no matter what our frame rate is. Now you noticed in our styles, we removed this -1000 in order to see how that works. What I want to do is I want to keep this at -1000, but when we start our game, I want to be able to put our bird in the correct position. So I'm going to create another function here, and this function is going to be called setUpBird. And this is essentially going to be our start function. So what I want to do here is I want to set our top, and I just want to take our window.innerHeight, and I want to divide it by 2. So I'm just going to set our bird in the very middle of our screen. Then in our script.js, let's make sure we import that setUpBird function. And then whenever we're handling our start, let's just make sure we call setUpBird. So now when we click start, you're going to notice our bird is put dead center in the middle of our screen for the start of our game, which is exactly what we want. Another thing we want to do inside this class is to handle how we can actually jump. So we need to add an event listener for that. So I'm going to say document.addEventListener. I want to do this on key down, and I want to be this function called handle jump. Let's say handle jump just like this. So whenever we set up our bird, we're going to add this event listener. And another important thing to note is we want to make sure we also remove this event listener every time we set up our bird. And that's because if we start a game the first time, there'll be no event listener and then it'll add one. So that'll be fine. And then when we start our game the second time, we're already going to have this handle jump function. So we need to remove it and then re-add it. Otherwise, we're going to get compounding event listeners where every time they click space, it's going to call this function 8, 9, 10 times, depending on how many times they've restarted the game. And that would be very bad. So we need to make sure we remove it first and then add it. Then down here, we can create that handle jump function, which takes in our event. And this function is going to be really simple. We just check to see if e.code is equal to space. And we're going to say if it is not equal to space, then we just return, essentially leave out this function and don't do anything. Otherwise, if they did hit space, we're going to create a variable, which is called time since last jump, and we're going to set it equal to 0. And then all the way at the top up here, we're going to create that time since last jump variable. So time since last jump, we're going to set it to the largest number possible. So number.positive infinity. So by default, it's going to be this huge number. And then here inside of our update bird, we can essentially check our time since last jump, which we can keep updating and say, hey, is this time since last jump less than our jump duration? So we're going to create a variable called jump duration. We're going to set it equal to something like 125. So 125 milliseconds is how long our jump is going to last. Then here we can say if our time since last jump is less than our jump duration, then what we want to do is make our bird go up instead of down. So let's move this code up into here. And instead of a plus, we're going to put a minus. And then otherwise, we're going to have an else statement here, and this else is going to move the bird down. So let's just copy this, and this is going to be our plus, which moves the bird down. So if we're jumping, we move the bird up, otherwise we move the bird down. And then at the bottom here, we're going to take our time since last jump, and we're going to add our delta onto it. So every single frame, we add the time of that frame onto our time since last jump, so it's going to constantly be going up, and then every time we hit spacebar, it's going to reset back to 0, which is going to allow our bird to move up. Now if I save and I come over here and I click space, you can see the bird moves up as I click space, which is exactly what we want. And it'll go down and then up when I click space. So now that we have a bird that can move around, the next thing we need to do is add in a win or lose condition. So if we hit the top or bottom of the screen, we want to automatically call that a lose. So I'm going to create another function. We're going to export that function, and it's going to be called getBirdRect. And this simple function is just going to return to us the position of the bird on the screen. So we're going to say bird element.get bounding client rect. And this is going to give us essentially the top left, bottom right of our bird, so we can use those positions to determine if the bird has gone off of our screen. Then in our script, let's just make sure we use that getBirdRect function right here. And then we're going to create a brand new function called checkLose. We're going to put this inside of an if statement. So if losing is true, then here we just return handle lose. And the reason we're doing a return here is because we want to make sure that we don't update our request animation frame. So it's going to stop our game completely whenever checkLose is true. And then we can just create that simple function checkLose right here. Now in this checkLose function, let's get our bird rectangle. So we'll say bird rect is equal to getBirdRect. And then we want to just have a simple check to see if it is outside the world. And this is going to be equal to if our birdRect.top is less than 0, and that's because the top of the screen is always considered 0. So if the top of our bird is less than 0, it means it's over the top of the screen. Or if our birdRect.bottom is greater than the window.innerHeight. So that means is the bottom of our bird past the bottom of the page, because the bottom of the page is going to be this window.innerHeight. If so, outside world is going to be equal to true. Then here we can just return our outside world. And if we just change that up a little bit, save, click space, and as we move to the bottom, as soon as we hit the bottom, it's going to count as a lose. And if we just refresh the page and jump all the way to the top, as soon as we hit the top, it's going to count as a lose and the game stops running. That's exactly what we want, but now we need to make this handle lose code work as we want. So the first thing we need to do is take our title, and we want to remove the hide class, so it'll show back up. And we also want to remove the hide class on our subtitle. So let's make sure up here we select our subtitle, which is data subtitle, just like that. So now whenever we lose, we're going to reveal our subtitle and our title. And for our subtitle, we want to change the text content to be equal to something like 0 pipes. This is going to be the number of pipes we pass by. For now, we're just going to placeholder it to 0. So let's save and hit space and see when we get to the very bottom, it now says press any key to start, 0 pipes. That's what we want. The only other thing we have left to do here is to make it so we can restart the game. So I'm just going to copy this event listener all the way up here, paste it down here, and now whenever I click a button, it's going to restart our game from the beginning. So when we click space, I hit the bottom. Now I click another button, you can see our game restarts again. Click another button and our game restarts again. Now, one important thing I want to do is I actually want to set this inside of a set timeout, and that may seem a little bit weird, but the reason I'm doing this is because it's often common that you're going to lose and you're going to be hitting the spacebar a lot as you're playing the game. So I want to make sure there's a small delay, for example, 1/10 of a second. So after you lose, it's not going to count any inputs. So if I'm hitting spacebar a bunch of times, this event right here won't fire again. So it won't automatically restart the game. It'll wait a little bit and then it'll let you restart, just so you don't accidentally restart if you don't want to. Another important thing we need to do is make sure that in our handle start, we set our last time equal to null. And that's because up here we have this simple last time equal to null check to make sure we reset all of our timers to make sure our delta is correct. So we need to make sure that when we start our game, we set it equal to null. That way it doesn't carry over the previous value and do some weird calculations. And again, you can see that's going to work fine. I click space, you're going to see it's work. If I get rid of this line of code, and I lose the game, and I wait a period of time, so we're just waiting around a little bit. Now I click space, you can see I've immediately lost the game again. The bird's nowhere to be seen. And that's because the time inside this update loop was continually counting up, but our last time was stuck where it was before, so there was a huge delta difference, which caused our bird to shoot all the way off the bottom of the screen. And this simple trick right here fixes that problem. Now the next step for us is going to be adding in pipes, which are going to be the things that we have to jump through. So in order to look at that, we want to first jump over to our HTML to kind of give us some styles for how we're going to design these pipes, and then we can move into the JavaScript. So I'm going to create a simple div with the class pipe, and inside here we're going to have a top and a bottom. So these are going to have a class of segment and top, and then the bottom is going to have segment and bottom instead. And this is going to be how our pipe is comprised. So then inside of our CSS, we can start styling all of those different things. So our pipe is going to be real simply a position absolute element. It's going to have a top of 0 and a bottom of 0, so it spans the entire height. And we're going to give it here a width. And this width is going to come from our JavaScript. It's going to be a variable. So we want to make sure we just do a simple calc with our variable. And this variable is going to be our pipe width. And we're going to multiply that by 1 pixel. And again, this is coming straight from our JavaScript. For now, we're just going to put it in our CSS so we can play around with what it looks like. Let's just set it to 120. There we go. And then same thing for the left position of our pipe. This is going to be coming straight from our JavaScript. So I'm going to copy this down, but instead of pipe width, we're going to say pipe left. And here, we're going to say our pipe left is just going to be set to like 100. It doesn't really matter. So now when I save, you'll notice nothing actually happens, but now we have a pipe on our screen. In order to see it though, let's select our pipe. And here we want to get that segment class, which both our top and bottom have. And here we're going to make our position again absolute. We're going to set the width to 100%, so it's going to fill the entirety of this pipe parent. And we also want to set the background color to a nice green color. So we'll use HSL again, 100, 75%, and 50%. Now, when we save, again, you'll notice nothing's happening, and that's because these don't have a height yet. So the next thing we need to do is select each portion. So we're going to have our top, for example, which is going to have a top of 0, pretty self-explanatory. And the bottom is going to be a variable that comes straight from our JavaScript again. So I'm going to copy this down, and this is going to be our whole top right here. And this whole top, we're just going to set up here, whole top, let's just say 200 pixels. So it'll be 200, just like that. So now you can see the top portion of our pipe is showing up. It's a little bit tall actually, so let's do 100, or actually 500. So our hole right here, the top is 500 pixels away from the bottom of our screen. That's great news. Next, we need to do the bottom portion of our pipe. So here, the bottom is going to be set to 0. And the top here is going to be the thing coming from our JavaScript. And this calculation is actually going to be quite a bit more confusing. So first what I want to do is I want to take 100 VH and I want to subtract that from the value that I'm going to get, which is calculating this whole variable right here. So right now, all I've done is I've taken 100% of our height minus this whole top area. And now when I save, you're going to notice our bottom pipe, if I make this our bottom, is perfectly matched up with our top pipe. We essentially want to have a hole in this pipe, which is where our hole height is going to come in. So I'm going to take another variable, again, coming straight from our JavaScript, which is going to be called hole height. And this hole height variable, again, we just multiply it by 1 pixel to convert it to a pixel value, is what we want to make sure we add onto this to give us some space. So if we come up here and we say that our hole height is 120, and I save, you can now see there's 120 pixels of gap between them. If I change it to 220, you can now see there's even a larger gap. If I change it to 20, it's a very small gap. 120 is a pretty good number. And again, all of this is going to be set in the JavaScript, which is why we're multiplying by 1 pixel here to make it easier to use this in JavaScript. So this right here is all the CSS we need for our pipes. So the next thing I want to do is actually create a brand new JavaScript class called pipe.js, which is going to handle all of our pipe related stuff. And the first thing I want to create is a function for actually creating a pipe. Pretty self-explanatory because we want to create these pipes on a certain interval that are just going to show up on the right side and move to the left, and we're going to jump through them. Pretty straightforward. So here I want to get a pipe element, and this pipe element is going to be document.createElement, create element, and it's going to be a div. And I also want to get a top and bottom element. So I'm going to create a simple function for that called createTypeSegment. And it's going to take in the position of that. And for example, here we can just say our top elem is equal to document, I'm sorry, not document, it'd be createTypeSegment, createTypeSegment, and we would pass in top. We could do the exact same thing for our bottom. And right here, this would say bottom. Now this function is really straightforward. We're going to create a segment, which is just creating a div. We're going to call it segment. And we're going to add some classes to that. So we'll say segment.classlist.add. We want to add the class list of segment, and we also want to add in the class list of the position. And then we just want to return that segment down here. So this is a very straightforward function. Now up here for creating our pipe, it gets a little bit more confusing. We first want to add our top and bottom to our pipe. So we can just say append top elem, and we can do the exact same thing for appending our bottom element. So now our pipe is essentially constructed. All we need to do is set all those CSS variables that we're using right here, our width, our left, our top, our height, and so on. Also, we need to make sure that our pipe element has the correct class. So we're going to add that class list of pipe. There we go. Now what I want to do is I want to take our pipe element, and what I want to do is I want to take the style, and I want to set a property. And this is going to be one of those custom properties. And this one is going to be where the top position of our hole is going to be. And to do this, we're essentially just going to calculate a random number between. And this is a function we're going to create where we're going to pass in a min and a max. So let's create that function. Call it random number between, which takes in a min and a max. Now this function is pretty straightforward. All we do is we take a math.floor of a math.random, and that's because math.random returns us a number between 0 and 1, but it never actually returns 1. It'll always be like 0.9999, never higher than that. So we're going to get that random number. We're going to multiply it by a little formula, which is our maximum minus our minimum plus 1. So this max minus min just allows us to get a value in the range of our maximum and minimum, and adding 1 is important because we're doing our floor out here, and that's just offsetting the floor that we're doing. And then finally, at the very end, we're going to add our minimum back in. So by subtracting max/min, this will give us a random number between 0 and essentially the difference between our maximum and minimum. We add our minimum in here, and now it's going to give us a number between our minimum and our maximum. And by using math.floor, it makes sure it gives us a round number and not a decimal number. Now, you may think that right here, all we need to do is essentially get a value between like 0 and the window.innerHeight, but this is actually incorrect. If we do this, we're going to have some of our holes show up off the screen, which is obviously really bad. So instead, we want to base these values off of our hole height. So let's come up here. We're going to create a simple variable called hole height, and we're going to set this variable equal to whatever our hole height is, let's say 120. Then here, what we want to do is we want to make sure our holes don't start at the top of our screen. We want to have a little bit of pipe showing. So we're going to use our hole height here times 1.5. So this is for the very bottom hole down here. So we're making sure we leave at least one hole height worth of room plus an additional half of a hole height. That way the pipe is always showing on the bottom of the screen. It's not a hole directly touching the bottom of the screen. And then what we want to do is we want to take our window inner height and we want to subtract our hole height times 0.5. And this again will make sure there's a little bit of pipe showing at the top of the screen and our hole doesn't actually touch the top of the screen. And this right here is going to be how we get the top of our hole for our pipe. Now next I'm going to do something a little bit interesting. I'm going to create a variable called pipe, and this is going to be a variable that has a bunch of helper functions in it so that we can interact with our pipe much easier. One of those is going to be a get function for our left property, and a set function, again, for our left property. And we can put a value in here, and this is going to work just like we did with the bird. So for getting, we want to return. We want to make sure we parse our float. So return, parse float. And what we want to do is we want to make sure we get our computed style for our pipe element. And we want to make sure that we get our property value, which is going to be here for our pipe left. Then for our set, we're going to do a very similar thing. Pipe element dot style dot set property. And we want to make sure here we're going to be setting that pipe left to the value being passed in. Very straightforward. That's all we're going to do right now for our pipe, but we can actually set our left here by saying pipe left equals, and we want it to start on the right side of our screen, so we're going to use our inner width. That's going to put it very far all the way to the right side of our screen. Then we can take our document.body, we can append in the pipe element, so this is going to add the pipe to our screen, and then we can also take this pipe helper and we can push it to a pipe variable. So we can say pipes.push in the pipe. And let's just create that variable all the way up here, const pipes is equal to an empty array. So this is just going to be an array of all the different pipes that we're using that are going to be rendered on the screen so we can easily interact with all of them. So now let's actually create our update function so we can actually create these pipes, because right now we have a function for creating them, but we have no way to create them. So let's create our update pipes function. And inside of here, all I want to do is first create a variable called time since last pipe. And I want to add in that delta. And that delta is passed in right here. So this variable let time since last pipe is going to start out at 0. And then every single change that we do for updating our pipes, we're constantly adding 1 to that. Then we're going to say, hey, if our time since the last pipe is less than our pipe interval. And this pipe interval determines how often we create pipes. So up here, we can create a variable called pipe interval. Now this variable, I'm just going to set to 1500, for example. So every 1500 milliseconds or a second and a half, it's going to add a new pipe. So here we can just say create pipe, and that's going to create us a pipe. And also I want to take our time since last pipe, and I want to set it equal to our time since last pipe minus that pipe interval. And we can actually just change this to be a minus equal to make it a little bit simpler. And that's just making sure our time since last pipe is resetting itself. We could set it to 0 here, but technically that'll be off by a few milliseconds, and this will be more accurate. So now we're creating a pipe every second and a half. All we need to do is make our pipes move to the side. So we could say pipes.for each pipe. What I want to do is I just want to move it to the side. This is really easy to do because I can just say pipe.left is equal to pipe.left minus delta times our pipe speed. And this is exactly what we did for our bird. And we just need to specify our pipe speed. And for this speed, let's just do like 0.75, for example. So now they're moving to the left, and we're creating a new one every second and a half. Now if I just come over to the index, let's remove this pipe that we have currently on our page, and let's see if this works. I'm going to click the spacebar, and you can see nothing's actually happening. It's not creating the pipes like we would expect. And that's because in our script, we're not actually using those pipe classes. So all the way at the very top here, we need to make sure we just copy this down essentially. And this comes from pipe.js. And we want to make sure we have our update pipe function. And we're going to call that down here, update pipe. We're going to pass it in the delta. Now let's see if this actually works. When we click space, you're going to notice we have an error. Nothing is actually working over here. And if I inspect, we should have some errors in our console. You can see the requested module pipe.js does not provide an export named update pipe. It's because it's called update pipes. So let me just change that. There we go. Now when I click space, you can see we're obviously having some errors. It's essentially creating a wall of different pipes. Let us go look at our pipe code real quick. You'll see immediately I have time since last pipe is less than our interval. We want this to be greater than our interval. And that's because whenever our time since last pipe is greater than 1500, then we want to run this code, subtract the amount, and wait till it counts back up again. This should hopefully fix that error a little bit. So if we just hit spacebar, you can see that that has now fixed the error. And it's every second and a half, we're getting a new pipe showing up on the screen. And it has, for right now, all the positions for the holes and such being randomized completely. And because of this, we can actually remove a lot of the code from our CSS here. For example, this whole top and this pipe left can be completely removed. Also, our hole height and our pipe width, we also want to remove from here. But when we do that, it's going to break our code because we're not setting those anywhere. So in our pipe.js, let's create that setup function that we created for everything else. So this will be called setup pipes. And in here, I want to take our document and I want to get the document element. I want to get the style, and I essentially want to set a property. And this property is going to be for our pipe width. And we're going to set that to a pipe width variable we're going to create. And I want to do the exact same thing here for our hole height. So I can say hole height and that is set to whole height. So our pipe width we know is 120. So let's just say pipe width is 120 because we're going to be using these variables in just a little bit. So now if I go into our script, I make sure I get that setup pipes, and I call that setup pipes inside of our start. And we click space over here, you can see that hopefully this should be working as expected. You can see we get a pipe right here, we get a pipe right here. So it looks like everything is working as we would expect. All the heights are randomized, they're showing up on a set interval, and it's working like we want. There's a few extra changes we can make though. One thing is that inside of here, our time since last pipe, we want to make sure we set this in our setup pipes. So we can say time since last pipe, and let's just set it to our pipe interval. So that way a pipe spawns immediately right when the game starts so that people don't have to wait for a pipe. Also, when we're updating our pipes, one interesting thing is once they go off the left side of our screen, we don't care about them anymore at all. So we should actually remove them from the screen. So in our create pipe, I want to create a really simple function called remove. And this remove function is going to remove the pipe not only from our screen, but it's also going to remove it from this pipes array up here. So inside of remove, all I want to do is I want to say pipes, and I want to set that equal to a filter for our pipes. So we're going to say pipes.filter. We're going to take our p, and I just want to see if it's not equal to our current pipe, this current pipe right here. So if it's not equal to the pipe, perfect, that's good. Then I'm going to take our pipe element and I want to remove it just like that. So essentially what this code is doing is it's removing our pipe from the array and it's removing it from the screen once we call this remove function. And then inside of our for each, we can just check to see, hey, has it gone off the side of the screen? So here, if our pipe.left plus our pipe width is less than 0, that means it has gone off the side of the screen. So we can just return pipe.remove just to get rid of the pipe and to make sure we don't run the code down here. So now once the pipe goes off the side of our screen, it should hopefully remove itself from the screen. And if we inspect the page and I just pull up the elements tab here, you should see the pipes being added. And then once they pass off the side of our screen, you should see them being removed. But of course, it looks like we ran into an error in our console, assignment to constant variable. That's because we need to make sure pipes up here is not a constant variable. That should fix that bug. So now if we go back to the elements tab, you can see that we have a pipe being added to the screen right here. And as soon as they go off the edge of the screen, they get removed and then a new one's being added off to the side. And that's working just like we expect. Now, the next thing I want to do is essentially count the number of pipes that we pass through. So let's say let past pipe count. And in here, we're going to say past pipe count is equal to 0. So every time we restart, it's set to 0. And then let's just create a simple function. We're going to say export function get past pipes count. And we just return our past pipe count. And then every time we remove one, we just take our past pipe count and we're going to add one to it. So now inside of our script, we can use that function that we just created, which is called get past pipe count. And then inside of our handle lose, instead of setting this to 0, instead we can set it to our get past pipe count. So now if I just hit start and you can see we passed by 1 pipe, we passed by 2 pipes. Let's just lose the game here. We actually passed 3 and you can see it says 3 pipes. So now it's actually correctly counting the number of pipes that we pass. One other thing that we need to do all the way up here is we need to make sure we clear off all the pipes on the screen when we click start. Because as you can see when I click start, the pipe that was already on the screen actually was still on the screen. That's really bad because it would cause you to automatically lose. So here, all I want to do is say pipes.forEach pipe. I want to call that remove function, so pipe.remove. That's just going to get rid of all the pipes that are currently on the screen. So if we lose with that pipe on the screen, click start, it now deletes itself immediately, which is a much better user experience. Now the final step we have to do is to make it so that when we collide with one of these pipes, it actually causes us to lose, because right now the game is really easy when all we have to do is just do in the middle of the screen and not actually worry about the pipes at all. So in order to do that, let's go down here to our pipe and we're going to create another function called rext. And this rext function is essentially just going to get us the rectangles for our pipe. And we know the pipe has a bottom and a top segment. So we can say top element.get bounding client rect. And we can do the exact same thing for our bottom. This is going to be the top and bottom of our rectangles for our pipe. So we can get both sections. Then we can create a simple function, which is just get pipe rex. And this simple function is going to loop through all of our pipes. So we're going to do pipes. And we want to just get a flat map. So we're going to map through all of these, looping through them. And for each one of our pipes, all I want to do is get pipe.rex. So what this is going to do right here is it's just going to say, hey, for each pipe, get us all of the rectangles for them. And by saying flat map, it's going to take the array of arrays and convert it into one-dimensional array instead of a multi-dimensional array, just so it's easier for us to work with. This function essentially gets us all of the rectangles for the top and bottom portions on all of our different pipes that are on the screen. Then in our check lose function, we can see if we're interacting with any of those pipes. If we've collided with them, we're going to say that we lose. So in order to make this easier, we're first going to create a simple function called isCollision, which is going to take in two rectangles, rect1, and it's going to take in a rect2. And here we just want to return if they have been collided with each other. And this may sound like it's complicated to do, but it's actually pretty straightforward. We just want to say if our rect1 dot left side is less than our rect2 dot right side. So if the left side of our first rectangle is to the left of the right side of our second rectangle, that means that our left side is intersecting with the right side. That's so far good. Then we could do the exact same thing, but we can say, hey, if the top of our rect is less than the bottom of the other one, then that means the top is above the bottom of the other, so they should be interacting with each other. Then we can say, hey, if the right side of this one is greater than the left side of the other one, again, they're going to be overlapping with each other. And then finally, the very last thing we can do is to check if the bottom is going to be overlapping with the top. And that right there is how we're going to write all of this code for the interactions. It may sound pretty complicated, but essentially all we're doing is just to make sure that any portion of our rectangle is inside the other rectangle. And this is going to be how we calculate our collision. And then up here, we can just say, hey, const inside pipe, we can say get pipe rex right there. And this automatically imported at the top for us, which is great. What I want to do is I want to call the sum function on this, which is going to return true if any of the values of the function here return true. I just want to say, hey, is there a collision between one of the rects here and our bird rect? So is one of the pipe parts connecting with our bird rectangle? If so, inside pipe is true. And we're just going to return whether or not outside world or inside pipe are true. So now if I play the game and I run into a pipe, you can see that it counts as a loss. And in order to make the game a little bit easier, let's make our hole height a little bit higher. We'll say 200 here. And now if I'm actually able to successfully get through one of the holes, if I'm able to get through it, there we go. And now I collide. You can see it worked correctly. It says that we were able to pass through one pipe, click space, and now we can start the game again. And as long as I'm going through the holes, it's going to work just fine. And that's all it takes to create Flappy Bird. If you enjoyed this, check out my other game development tutorials linked over there. And with that said, thank you very much for watching and have a good day.